Hello and welcome to this lesson on flame emission spectroscopy. In today's lesson, we will understand the principles behind flame emission spectroscopy. We will also explore the process of flame emission spectroscopy as an instrumental method for analyzing metal ions. So far, you've learned how instrumental methods provide more accurate, sensitive, and quicker results, better able to quantify substances, and potential for automation compared to traditional techniques. With this motivation established, we can dive into flame emission spectroscopy. Flame emission spectroscopy is used to analyze metal ions in solutions. When we introduce a sample containing metal ions to a flame, the heat energy from the flame excites the electrons in the metal ions. This means that the electrons absorb energy and move to higher energy levels. However, these excited electrons are not stable at higher energy levels and eventually fall back to their original, lower energy levels. As they do so, they release the absorbed energy in the form of light. The emitted light consists of photons with specific wavelengths, which correspond to the energy differences between the electron energy levels in the metal ions. Each metal ion has a unique set of energy levels, so the wavelengths of light emitted are characteristic of the specific metal ion. Using this characteristic, the emitted light is directed through a spectroscope. The role of the spectroscope is to disperse the light into its component wavelengths, creating what we call a line spectrum. Unlike a continuous spectrum, which shows all wavelengths of light, a line spectrum shows distinct lines that correspond to specific wavelengths. The output line spectrum is essentially a pattern of lines, with each line representing a particular wavelength of light emitted by the metal ions. This pattern is like a fingerprint for each metal ion, as different metals will produce different line spectra due to their unique electronic structures. To analyze the metal ions present in the sample, we look at the positions of the lines in the spectrum. By comparing these positions with known line spectra of various metals, we can identify which metal ions are present in the sample. Additionally, the intensity of the lines can be used to determine the concentration of the metal ions, although for GCSE level, the focus remains on identification. Let's look at some extension knowledge on mass spectrometry. Flame tests tell us what metals a sample contains based on the color the flame produces. Advanced analytical techniques such as mass spectrometry provide much more detailed information. When a sample is placed into a mass spectrometer, the mass spectrometer will break down the sample into smaller charged particles known as ions. Each ion has both a mass, how heavy it is, and a charge, often positive. The mass spectrometer will separate out the ions in the sample based on the mass-to-charge ratio of the ions. Mass-to-charge ratio directly compares ions' charge and mass. The equation for this is the ion's mass divided by the ion's charge. As each ion's mass-charge ratio is different, scientists can determine exactly what molecules are present and the amounts of the molecule present within samples. Mass spectrometry can detect tiny amounts of chemicals, making it useful in medicine, forensics, and environmental science. In today's lesson, we delved into the principles and process of flame emission spectroscopy as an instrumental method for analyzing metal ions. We learned that when a sample containing metal ions is introduced into a flame, it emits light. This emitted light is then passed through a spectroscope, which disperses it into a line spectrum. By comparing the produced spectrum to known spectra of various metals, we can identify the metal ions present in the sample. This technique is widely used in various fields, including environmental testing, medicine, and industrial processes, due to its precision and efficiency. Watch the rest of the GCSE chemistry course at Sophos Education.